This is the project presentation of Group 18 for AAI 695 Applied Machine Learning course. Our topic is Lending Club loan data from Kaggle. My name is Harsh Agrawal and my teammates are Blessy Vincent and Ria Kale. In this presentation, we will go through the major steps of the project, which include a quick introduction of the dataset and the features, some pre-processing to prepare the data, EDA to ensure we understand the data patterns as well as the correlations, and finally, the machine learning and statistical analysis we obtain from the entire process. So let's begin with the introduction of the Lending Club loan dataset. Our main objective is to accurately predict any potential borrower's likelihood to pay back a loan based on the information made available at the origin of the loan. This includes all sorts of personal information like credit score, salary, other mortgages, age, as well as some of the loan information. Hence, we try to predict if the loan is likely to forfeit the deadline. The lender has these features made available to him at the origin and can use the analysis provided by us. Since there are broadly only two categories, meaning either paying the loan or forfeiting, this becomes a binary classification task. We use the Lending Club dataset from Kaggle, consisting of 2.2 million records from 2018. It has 150 columns, which makes it an extremely huge dataset to work with. Even features of the loan like monthly payment interest rate, income, terms of loan are made available at the prediction day. The final target column called loan status is divided into fully paid, current, charged off, grace, late, and defaulted targets. The Lending Club Wikipedia thoroughly explains the process of prediction that has been used in the past decade, with the platform reaching its peak in December of 2015. This makes this data the largest peer-to-peer lending platform data, amounting to over $16 billion as of 2015.
So we get to pre-processing the Lending Club loan data. The major things that need to be dealt with are the NaN values, since both categorical and numerical values have a lot of NaNs reaching well over 50% in extreme cases. We also need to merge and drop unnecessary columns, as not all 150 columns are equally valuable. To decrease the load, we can use dimensionality reduction techniques like LD and PCA, making sure no data is lost, and sampling will deal with the disbalance in the dataset at the present time. Firstly, the NaN values. Since multiple columns have a very high NaN values, we simply drop any columns having over 20% NaN values, as predicting these can ruin the integrity of the dataset. We also drop irrelevant columns like ID and URL, and some of the numerical value columns having the NaN replaced with the mean of the column. Next, we combine some of the target values to make them into a binary classification problem. For example, default and late are considered to be negative outcomes, and clubbed while outcomes like grace are dropped since they are too ambiguous to properly predict. Next, we analyze the data before we move to machine learning. A correlation matrix explains the relation of the most import values with the loan status. Values like FICO range have a high absolute correlation, whereas values like interest rate and total payment seem to have a lower absolute correlation. So we plot the significant values to compare with each other. We observe that almost all values end up having a 0 or a very low correlation value with the actual loan status, whereas some particular columns like recovery fee have a considerable positive correlation to the loan status. We observe that the installments column can be considered to be almost normally distributed, meaning there is a very high number of people who have the installment value in the mid-range of the dataset. Also, for the FICO range, a decreasing trend is observed, where in lower the FICO range, higher the number of observations. The number of fully paid loans also drop off in a hurry as we go higher in the range. These are a few outliers in every category we observe against the FICO range, but since they seem to be equally spread out without much randomness, they would not significantly disturb the process.
Now, we finally get to the solution for the Lending Club loan data problem. First, we use random forests, logistic regression, and XGBoost as the main models. We also use dimensionality reduction techniques such as LDA and PCA. We make sure that we balance the target columns using samplings. After all the pre-processing, random forest and logistic regression seem to perform extremely well. Even PCA and LDA only hinder the accuracy of the model, which is suspected to be the result of lost accuracy. On the contrary, sampling increases the accuracy by a very tiny margin but is nothing significant. The best performing solution by far is the XGBoost, as the consistency and the accuracy along with the F1 score remains unmatched. Finally, when we compare the F1 scores, we see that overcomplicating the model with sampling and dimensionality reduction tends to have a negative effect on the model, but a stronger model like XGBoost, which can learn huge datasets with ease, performs very well on its own.
Greetings, Professor. Hope you're doing well. I'm Blessy Vincent Tyagaraja. I'll be taking through the slides of statistical analysis, through which we have implemented tests to understand few hypotheses of our dataset. So we have implemented a z-test. The reason why we have implemented a z-test because our sample size is huge, and a t-test will be illustrated in terms of sample size less than 30. And the z-test uses a formula of x minus mu by sigma, where x is going to be the target variable and mu is going to be the population mean and sigma is the population standard deviation. And the z-test will also help us to understand the location of a score in the distribution. So if you check here, we have used the learn status column, which consists of 0 and 1, which is our target binary variables. And we have designed our null hypothesis in such a way like there is no significant difference between the mean loan amount of paid and charge-off loans. Our alternate hypothesis is going to be there is a significant difference between the mean loan amount of paid and charge-off loans. And if you check the results of the z-test, you can see the loan amount columns, interest rate, as well as installment all have a negative z-score. So what does that mean? Z-score will help us to understand the distribution of the variable. So it means the loan amount is 75.212 below the mean. And similarly, the interest rate is 296.074 below the mean. What does the p-value mean? The p-value, which gives 0.0, that means it is less than 0.5. So hence, we reject the null hypothesis and accept the alternate hypothesis. So thus, the results of z-test can be illustrated. Next, we have implemented a subset selection. So in the subset selection, what we have done is we have implemented few methods so as to understand the importance of futures across the data set. We have totally 151 columns. Out of those, we need to understand what are the columns which is primarily important. On part of this, we have implemented two methods. One is forward selection as well as the backward selection. So what happens in forward selection is we start from the beginning of the data set, that is from 0 predictors, and then start adding the predictors one by one until we reach the end. So there are total 151 columns. We iterate through all 151 columns to understand what is the important column out of all the 151. Here we start by splitting the data set into a fraction. And we scale the data set and split the training as well as the testing in the ratio of 1:1. We have also implemented the forward and backward selection in terms of a logistic regression. If you check the results, we could see few columns which are of primary importance when done through the forward selection. Similarly, we implement the backward selection. So in backward selection, what we do is all the splitting and training happens in the same way. The only difference is the futures are dropped after every iteration. That is, we take the whole data set and we start dropping the columns one by one until we reach the beginning, which is going to be having only one column. By doing this, we can understand what are the columns that are being implemented as part of the forward as well as the backward selection. So by doing the subset, it will help us to understand what are the primary columns which has been used as part of the data sampling. So that comes to the end of our slides. Thank you very much, Professor, for your guidance all through the course. It was really exhilarating throughout the course. Thank you very much. Winding off.